Flack math! Give me some math and I'll give you some flack. Flack math!
So lesson 97. So whenever you have two intersecting lines like this, always it forms four angles. Okay, so either you're going to, and most of the time you're going to have two obtuse angles and two acute angles that form, unless those lines are perpendicular, which makes four right angles. Turn the page. Come on. Okay. Yeah. Okay, so this is what perpendicular lines look like. They're still intersecting lines, but instead of two obtuse and two acute, this is four right angles. Okay, so these are perpendicular lines. Okay, and the little shorthand that we use is a capital upside down T. So perpendicular lines. Okay. And I'm sure we've talked about the Pythagorean theorem, but basically Pythagoras said that if you have a right triangle and you formed a square out of all the sides, so here's a square of the two legs, and then here's a square of the hypotenuse, then the area of the hypotenuse square would equal the sum of the area of the two squares on the legs. Okay, so geometrically, this is what he discovered. So if I put all the squares that were in this in here, it would fit perfectly. In other words, if we call this A, B, and C, the area of this square is A squared. The area of this squared is B squared. The area of this square is C squared. So A squared plus B squared equals C squared. You've seen this before, but this is, if you want to experiment with that, and it's a satisfying little thing. If you want to construct a diagram and do the square and just cut out little squares, you're welcome to do that. But that's a true deal. That's Pythagorean theorem. Okay. So there are certain combinations of counting numbers that work for this, but most of the time when you have a right triangle, you have irrational side lengths. So you're taking the square root of something that can't be square rooted or whatever. But let me show you an example. So let's see if we can find, here's example 1. I want to find the missing side. Okay. So here's a right triangle. Can you see it? One side is A, one side is 4, one side is 5. So I want to find A. So I think you guys have done this before, but let's just try it. So first thing I always start with is the theorem. So A squared plus B squared equals C squared. Now A and B are interchangeable. These are just the legs. So it doesn't matter which one goes with A and which one goes with B. But since we called this A, then let's just call this A, A. And here's our b, because that's the other leg. So a squared plus 4 squared has to equal 5 squared. Okay, well, let's do the math. A squared plus 16 equals 25. All right, we're trying to solve for a, so get rid of 16. So subtract 16. A squared equals 9. So if a squared equals 9, what does a equal? Square root of 9, which is 3. Okay. So this is an example where, hey, that turned out nice. You can actually take the square root of 9, and it's a 3. We call it a 3, 4, 5 right triangle. This, since they're all counting numbers, this is called a Pythagorean triplet. Okay, so this is a 3, 4, 5 triangle. We'll talk about that in a second. Let's see if we can do another example here. See if you guys can do this one. So the trick is trying to figure out which one is the hypotenuse. And it's really easy to tell because it's always opposite of the right triangle. Okay, so see if you can find P.
Go ahead, open. Is it 9 squared?
9 squared?
Yeah.
No. So how'd you get 9 squared? What'd you do first?
I did 4 plus 5, and then I just squared it.
Okay, so yeah, so you have to square 4, so you added before you squared. So yeah.
Micah's got an answer.
All right, Micah, what do you got?
Square root of 41.
All right, good job. So let's go back to the beginning. So remember A can be either 4 or 5. A and B are interchangeable, so it doesn't matter. So let's just say it's A. 4 is A and 5 is B. And P is the hypotenuse, so that's what needs to go in for C. So we're going to solve for P. So this is 16 plus 25 equals P squared. 41 equals P squared, but we don't want P squared, we want P. So square root both sides, and this is what you're stuck with. That is still a number, and it's still a side length, but it's irrational. So this 4, 5 square root of 41 triangle is not a Pythagorean triple because they're not all counting numbers. Okay, so that's your answer. And technically, when you take the square root of something, there's 2 answers, right? There's always the positive version and the negative version. Well, negative anything is not a side length, so we discount it. We don't need to include that. Okay? All right, let's try another one. So let's say my side lengths are a little bit trickier here. Here's my right triangle. I'm going to solve for K, and this is my hypotenuse. So see if you can find K.
Nathan?
A equals 6.
What'd you get?
6.
Yep. Good job. All right, let's plug it in. A squared plus B squared equals C squared. A, I'm going to say is K. B, I'm going to say is 5. And then C has to be square root of 61. So when you square a square root, what happens? It cancels itself out and you're just left with whatever's underneath the radical. So 61. So you get k squared plus 25 equals 61. All right, get rid of 25. So k squared equals 36. So k, the square root of both sides, k is 6. Good job. All right, let's do one more. And this is just an example where you just have to make sure your answer is simplified. Just like when we did fractions, you always have to make sure that your fractions are reduced. So that's a little hint for the final answer of this one. So try to get this answer. Go for it.
Go ahead, open.
All
I
right,
got what's it called? The square root of 208.
okay, that's right so far. Good job. So now you have to do the dirty business of trying to look for a perfect square that's inside of there that you can pull out. And the biggest one that I found was 16. So let's catch up with Elkin here real quick. A squared plus b squared equals c squared. They give us the two legs. So I'm going to say 12 squared plus 8 squared. And we have to find the hypotenuse. So 144 plus 64 is 208. So m equals the square root of 208. Well, 16 goes in there. So it's the square root of 16 times the square root of 13. So that's kind of a weird, I mean, it's hard to get there, but you just kind of have to go through that list of perfect squares and see what you think would go in there. Now, obviously, a perfect square like 25, well, 25 doesn't go into 208. So you can skip a lot of those perfect squares. But 16 goes in there 13 times. So square root of 16 is just 4. So your final answer is 4 radical 13. Does that make sense? All right, so here's the deal. When you do end up with all side lengths of a right triangle that are Pythagorean triples are counting numbers, these are called Pythagorean triples. So 1 was a 3, 4, 5 right triangle, right? Because 9 plus 16 equals 25. There's some other ones that are worth noting. So remember, and if you did this, like a 6, 8, 10, look at that. 36 plus 64 equals 100. This is just a multiple of 3, 4, 5. So it's kind of like an equivalent fraction. This is an equivalent right triangle of the 3, 4, 5 triangle. All they did was double the sides. So also 9, 12, and 15 would be another version of the 3, 4, 5 triangle. 12, 16, 20 would also be another version. But so this is just one of many. So 6, 8, 10, 9, 1 second. 6, 8, 10, 9, 12, 15, etc. All the multiples of that. Here's another one, a 5, 12, 13 triangle. 25 plus 144 is 169. Okay, and obviously all the multiples of that. Here's another, actually, one more. We've got an 8, 15, 17. So all the multiples of that. Okay, so those are just 3 examples of Pythagorean triples. Okay, so those are nice when you get those, but you can also, it's kind of a shortcut when you see something like this, and you see 6, 8, you know right away that this is a, oh, this is a 6, 8, 10 triangle, which is a version of 3, 4, 5 triangle, so that's 10. So that's nice when you can find that. They actually use this in construction a lot. When we built, when my brother and I built a deck off the back of my house, we wanted to make sure it came out at a right angle. So what we did, because using a little protractor doesn't really suffice for big construction framing projects, right? So what we did is we measured 3 over, and then we measured 5 or 4 out, and then we made sure that that diagonal, that hypotenuse, was 5 feet. So we didn't just do that because we're math nerds, but a lot of people, a lot of construction workers do this, and they do this a lot in architecture. So on site, it's nice to know that you have a right angle. You got to know. If you don't have right angles when you're framing a house or something like that, you're in trouble. Okay, so that's lesson 97. Let's move on to lesson 98. All right, we're going to talk about the distance formula and the slope formula. Okay, this is lesson 98. Distance and slope. All right. So the distance formula actually uses the Pythagorean theorem. Pythagorean theorem. Okay, so let me show you an example. So if I wanted to find the distance between 2 points, okay, so find the distance between 4, 2 and -3, -2. Okay, so if I were to plot these points, 4, 2 is right here. -3, -2 is right there. Okay, you see my 2 points? Here's 4, 2, and here's -3, -2. All right, so usually, like if this was just right here, then I could just count the squares, right? 1, 2, 3, 4, 5, 6, 7. So if it was -3, +2, and 4, 2, then I just count the squares because it's a horizontal line. So horizontal lines are easy. You just count the distance. And vertical lines, same thing. You can just count the squares. But it's not. It's a diagonal line. So I have to find this distance. Well, we could use Pythagorean theorem because look, I could draw a triangle here. Look at this. If I drew a triangle, that is a right triangle. Okay? So how do you calculate this distance? Well, you could just count 1, 2, 3, 4. So this has a distance of 4. And this has a distance of, let's see, 4. Yeah, it's 4 over plus another 3. So that's 7. Okay. Now, how do you find this side here? Pythagorean theorem. So a squared plus b squared equals c squared. Well, a squared is, you could kind of choose whatever you want. I'm going to just say 7. And 4 is b. That equals d squared. 49 plus 16 equals d squared. Let's see, 65 equals d squared. D equals the square root of 65, and you're done. All right, so this, you can always do this, unless the point is 1,456, 1,903,000, and then the other point is negative 1,506, whatever. Well, that's going to be hard to graph, right? You don't want to go a left million and whatever. That's going to be hard to graph. So what you can imagine, if you visualize that, oh, well, look what we did. This 7 just represents the distance between 4 and negative 3. You see that? Well, how do you calculate the distance between two numbers? You subtract them. All right, so this 7, well, there was a bug crawling on me. Sorry, that was disturbing. Okay, so this 7 is just 4 minus negative 3. And this 4 here represents the difference of the y values. Difference between 2 and negative 2. This is just 2 minus negative 2. Okay, so the distance, your a and b is just the difference of their x and y values. Okay, so let's just write that out here. So distance formula, I'm going to use a different color here. Distance equals, well, let's figure out what that was. We used the Pythagorean theorem, so this is x1 minus x2, and we squared it. And then we did the y1 minus y2. That's just the difference of the y values. And then the last thing we did was we square rooted everything. So this is the distance formula. It looks confusing, but it kind of makes sense because this is still just the Pythagorean theorem. Because remember, the Pythagorean theorem is just c squared equals a squared plus b squared. Or in other words, c equals the square root of a squared plus b squared. This is another version of the Pythagorean theorem. If I were to just take that square root step right away and not apply it right away, but just get c by itself, just square both sides. This is the Pythagorean theorem. So this a represents your x difference of x values, and b represents your difference of y values. Okay, so you can do it this way. Just draw it out, and you might need to the first few times, or if you want to just memorize a formula, well, you don't really have to memorize it too much, because if this makes sense to you, then you don't have to ever memorize anything. If the formula makes sense, then you don't have to memorize it. Well, it kind of makes sense because this is your left-right values, how long the base is. This is the height. Y represents height on a graph. X represents length, right? Okay, so a squared plus b squared equals c squared. All right, so that's the distance formula. Now, I'm going to give you an example, and you can just plug it right in. You could graph it if you want, but let's just plug it right in and see what happens. So here's example 2. Example 2 says this. I want to find the distance between 3 comma negative 4 and negative 5 comma 2. So let's just plug it into our distance formula and see what we get. So I'm going to do that. You can do it with me. All right, so it doesn't matter which one's x1 and which one's x2, especially in this formula. When it comes to when we get to the slope formula, it doesn't matter there, but you have to be consistent with your x and y values. So I'm just going to choose this as x1. So we're going to say 3. And I'm going to choose this as my x2, -5. So it's 3 minus -5 squared plus y1 would be -4 minus y2, which is 2, all that squared. So this is 8 squared plus -6 squared. So that's 64 plus 36. Oh, look at that. So the square root of 100, which equals 10. All right, now if I would have reversed these, and if I would have said, this is x1, and this is x2, this is y1, and this is y2, I would have gotten -5 minus 8, so I would have gotten -8 squared, which still would have given me a 64. And if I would have reversed this, I would have gotten 2 minus -4, which would have been a +6 squared, which is still a 36. So when you square something, it doesn't matter if it's positive or negative. You're always going to get the same thing. All right. So that is the distance formula. Now we could have graphed it and draw our little right triangle, use the Pythagorean theorem, and been fine, right? Well, I'm putting my coffee on my printer. Hopefully it doesn't spill. That would be bad. Okay, so let's move on to slope. Now slope, remember, slope calculates what over what? Do you guys remember the two R words?
Who said it? Audrey?
Rise over run.
That's right, rise over run. Okay, so rise, if you think about the coordinate plane, how high it goes. So this is going to be the difference of y. So the distance between y's. Distance between y values. Okay, so basically y1 minus y2. And then run is obviously the distance between x's. So how do you calculate distance between two things? You subtract their values. Okay, so this is x1 minus x2. Okay, now you could reverse these as well, y2 minus y1. So basically, it doesn't matter which one you choose for the first coordinate and the second coordinate. It doesn't matter, but you just have to be consistent. What doesn't work is this, y1 minus y2 over x2 minus x1. No, you can't do that. You got to be consistent. All right, so this or this. So to calculate the slope between two numbers, again, you could just graph it and see what happens. So I'm gonna do both here. So this is example 3, and I want to calculate slope between -3, 4 and 5, -2. Ooh, that was bad there. Okay, so 5, -2 is right there. -3, 4 is right there. So normally, if I wanted to calculate, I mean, you can draw a line if you want, doesn't matter. If I were to calculate slope, I have to figure out how much it rises and how much it runs. Okay, so I could do this. So let's see here. This, you could still draw your triangle and figure out how much it rises. So it goes down 1, 2, 3, 4, 5, 6. So it goes down 6, and then it goes right 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the rise over run it goes down 6 and then right 8. So how do you say down 6? Negative 6. How do you say right is positive? So negative 6/8 or negative 3/4. Okay, well, let's see if we can come up with a formula that does this for us so we don't have to graph it. Okay, so remember we call slope m because of all the letter m's in the word slope. So with our x values and our y values, we already talked about that. So we talked about the rise is the difference of y values. Okay, so I'm going to say, let's see here, 4 minus negative 2. So see how this is y1 and y2 over negative 3 minus 5. Okay, so chicken scratch, bok bok, that gives me a 6. This gives me a negative 8. So positive divided by a negative is a negative. Reduce that 3/4. Cool, right? So again, this is a formula where you don't have to memorize because it kind of makes sense. And if you forget it completely, you can always just graph it and then count the rise and count the run. Okay. So either way, are you guys comfortable with doing these? Does this make sense to you guys?
Getting some head nods.
Okay. All right. Good, good. All right. So that's all I got today. Your homework will kind of help you get through the rest of these. And we won't be tested on these concepts, I don't believe. So, but you will have homework on this. So, yeah, Schoology me if you have any questions. If you want to get some Flack attack points, you've got almost a half an hour to get some work done. So Zan, make sure you get at least 5 done, and then you can get that free problem set. But yeah, you guys good? Any questions?